Today we're going to take a look at verifying trig identities, and it's kind of like putting together a puzzle. We're going to be showing that if you look down here at all these examples, that these equations down here are equal. So a couple things we're going to go through here. First, the reciprocal identities, and we know these two. Cosecant is the reciprocal of the sine, secant is the cosine, and cotangent is the tangent. Tangent equals sine over cosine, and when you think about this, going back to our unit circle, we said this is our cosine and this is our sine. So tangent, sine over cosine. And then it comes up with this Pythagorean identity, which comes from this as well. Sine squared plus cosine squared equals 1. Well, that matches up Pythagorean theorem. So a squared plus b squared equals c squared. And then these two down below, they're just rearrangements of it. If we solve for cos squared, 1 minus sine squared. If we solve for sine squared, 1 minus cos squared. So a couple things that people like to do. There's some crazy algebra tricks here that we're going to look at. I shouldn't say algebra tricks, but if you're multiplying two fractions together, if there is a value on top and bottom, those reduce under 1, so it's c over b. You can't just reduce out the denominator here. When you're adding fractions, you can separate them if they have a common denominator, but if there's two parts on the bottom, it has to have a common denominator. So this is illegal here. Multiplication is commutative, so you can bring out that b here, but you can't separate it into two fractions. And then this is probably a really common one here. A lot of people like to say there's a b on top and a b on the bottom and reduce that out, but it has to be multiplied there. You can't do it with adding. So a couple of fraction hints. If you're dividing fractions, you keep the numerator, multiply by the reciprocal. So that's equal to y over x. If you have some messy fractions, we could fraction bust the top and the bottom. So this would be x plus 1. This would be yx plus y. And then this last one here, what's our fraction that we're going to fraction bust it by? We could multiply by xy, multiply by xy. So this would just be 1. This would just be divided by x plus y. So a couple hints here. Always change to sine and cosines. You could try combining fractions, separating, using a formula, particularly the identity. Factoring, simplifying something, and a couple hints. Make sure you copy carefully, start with the most complicated side, and don't undo what you just did, and also fraction bust. So the first one we're going to take a look at here. Personally, this is my favorite. Change everything into sine and cosine. So this is really 1 over the cosine times cotangent is cosine of x over the sine of x equals cosecant 1 over the sine of x. So if we look here, cosine over cosine is 1, so 1 over the sine of x equals 1 over the sine of x, and we have verified that. The second one, let's see what we can do. So first change to everything to cosine. So cosecant, cosine of theta over the sine of theta plus sine of theta over the cosine of theta equals 1 over the cosine of theta. Well, let's see if we multiply this in, that would be gone. So we'd have the cosine of theta plus, if we multiply it in here, sine squared of theta over cosine of theta equals, got to multiply it into here. Nope, sorry, we just multiplied into that left side, 1 over the cosine of theta. Well, I don't like fractions here, so let's fraction bust. Cosine of theta. So cos times cos, cos squared of theta, plus sine squared of theta.
Steve Schmidt, if you're in the building, please
so
call
this is that
6102.
Pythagorean identity.
Steve Schmidt, please call 6102.
The next one we're going to look at here. We got some fractions, but let's start the same way. So this is 1 over sine squared of x divided by cosine x over sine of x equals 1 over the sine of x times 1 over the cosine of x. So if we simplify this, we keep the first one times the sine of x. We flip that second one. Multiplying fractions, this is 1 over sine of x cosine of x. Well, what simplifies here? Let's see, we got a squared, so that's gone. So this one is left with 1 over sine of x cosine x equals 1 over sine x cosine x. So let's see, number 4 here. Cosecant of x. 1 over the sine, I'm just going to switch this to x, times the sine of x, minus sine squared of x, equals cosine squared of x. Well, sine over sine, so that's 1 minus sine squared of x equals the cosine squared of x. Well, that is the Pythagorean identity, so we're done. Let's see this next one. If we rewrite everything, the sine of x, 1 over the sine of x equals 1. Sine over sine, so 1 equals 1. And a lot of these here, they just take practice because it's a lot of using those hints, but it's just a lot of practice on these. So we have the cosine of x plus the sine of x times sine of x over cosine of x equals 1 over the cosine of x. Well, let's see if we simplify this. Cosine x, sine squared of x over cosine of x equals 1 over the cosine of x. Well, let's see, fraction bus, so multiply everything by the cosine of x. And we are left with, let's see, that would be cosine squared of x plus sine squared of x equals 1. Well, there's that P identity again, Pythagorean identity. So we're done. And we'll just take a look at a couple more, because I think you guys are probably getting the hang of this. So we have 1 over the sine of x times the cosine of x equals cotangent cosine x over sine of x. And we've proved it. Those are the same, because this is cosine of x over sine of x equals cosine x over sine of x. So if we take a look at number 8 here, we got the cosine of x times sine of x over cosine of x plus, this would be cosine x over sine of x equals 1 over the sine of x. So if we multiply this in, let's see, so this would just be the sine of x plus cos squared of x over sine of x, 1 over the sine of x. And this is another one where we could fraction bust this. And I bet we'll be left with that identity again. Because now let's see if I can fit it in here. Sorry, didn't leave enough space here. So this is sine squared of x plus cosine squared of x equals 1. So that's the Pythagorean identity.